Alright, let's look at the homework 2.8, problem number 4. Alright, so boat is pulled into a dock by a rope attached to the bow of the boat and the tip of the boat, and passing through a pulley up here, which is 1 meter higher than the bow of the boat. So you have, I'm gonna draw. Alright, so here I'm gonna draw a right triangle right here. And this is going to be 1 meter right here, right? And then the rope is pulled in at the rate of 1 meters per second, so it's pulled in this way at 1 meter per second. How fast is the boat approaching the dock when it is 9 meters from the dock? So this is 9 meters, right? So I'm gonna give variables for the changing quantities, right? So for example, here the distance between the boat and the dock is changing, so I'm gonna give x for that, right? And also the length of the rope here is changing, so I'm gonna call it, so since it's a rope, let's call it r. Alright, since we have a right triangle, we can immediately use the Pythagorean theorem to set up an equation saying that, let's see, we have x squared plus 1 squared, because 1 meters, is equal to r squared. Right? Then let's see, so we're using that, let's see, so 1 meter, we use that information there. And let's see, at the rate of 1 meters per second. So rope is pulled in, so we know that dr over dt is given to be 1 meters per second, but the r is shrinking, so it's a -1. Right, and when dock is 9 meters from the dock, so you have 9 meters, so x is 9 at that point. Alright, so we have that. Then what we're looking for is how fast is the boat approaching. So we're looking for dx over dt. Right, this is the guy in question. Right, so let's go ahead and take the derivative with respect to time. Alright, so take the derivative with respect to t. Right, derivative of x squared would be 2x. Then you have to multiply by dx over dt, which is what we're looking for. Derivative of 1 squared is 0 since it's a constant, so I'm not going to write anything down here. So this is equal to, derivative of r squared would be 2r. Then you have to multiply by dr over dt, because r is different from t. Alright, then since we're looking for, this is the guy we want, right? So we're going to just, divide through by 2x. So you're going to get this. So by dividing through by 2x, we can isolate dx over dt is equal to, and 2 and 2 cancel out, so you're going to get just r over x, dr over dt. Alright, so it looks like we have x is 9, and dr over dt is -1. And we still need to find r, but we can find r by plugging x equals 9 into the original Pythagorean theorem, right? So that would be, so 9 squared would be 81, plus 1, so that's 82. So maybe I'll just go ahead and write 82 is equal to r squared. Right, by taking the square root of both sides, and r is going to be plus or minus, but in this case we're talking about the length of r, so we're just going to take the positive one. So it's a square root of 82. Alright, so r is square root of 82, so this is going to be equal to, right, square root of 82 over x is 9, and multiplied by dr over dx is -1, right? So that's just the negative square root of 82 over 9, right? So I'm going to type it into a calculator, and I have to round the answer to 2 decimal places. So let's do that. Alright, and this came out to be about negative 1.01. Alright, so let's type this guy in. Alright, so it was when, let's see, so from the doc, so it's a 1.01 meters per second. So let's check submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.